This is an important problem of pair of straight line, and the problem is if one of the straight line ax square plus 2hxy plus by square, this is equal to 0, coincide with the straight line a dash x square plus 2h dash xy plus b dash y square equal to 0, and remaining two straight lines are at right angle, then show that this relation we have to prove. And another part of the problem is, instead being at right angle, if the remaining two lines be at angle theta, then show that this. Okay, here two problems are, we have to prove these two results. We here first prove the second result. Okay, in this part A, and we prove the first result in this lecture of part B. And here we let ax square plus 2hxy plus by square, this is equal to b into y minus mx into y minus m1x. And similarly we take a dash x square plus 2h dash xy plus b dash y square, this is equal to b dash into y minus mx into y minus m2x. Why this is y minus mx? Same, because we are given that two lines are coincide. One line of this and this are coincide, and another two line makes angle theta. That is, we take the remaining line with slope m1 and this with slope m2. Then we know that equating the coefficient we get m plus m1, this is equal to minus 2h by b, and from here m plus m2, this is equal to minus 2h dash by b dash, and another relation is m1, this is equal to a by b, and from here m2, this is equal to a dash by b dash. We name this is 1 and this is 2. Okay. Now from first two relation of 1 and 2, we get the relation as by subtracting them m1 minus m2, this is equal to 2 into h dash by b dash minus h by d. Okay, and by dividing the second relation of 1 and 2, we get m1 by m2, this is given by a b dash by b a dash. Okay, we get m1 minus m2 and m1 by m2 from 1 and 2. Now since it is given that remaining two lines makes angle theta, and we know that the formula of finding the angle between two straight lines is given by tan theta, this is equal to mod of m1 minus m2 by 1 plus m1 m2. Now we have to record the value of m1 m2. Okay, and we get the value of m1 by m2. So from this relation we get m1 by a b dash, this is equal to m2 by b a dash, and we get this is equal to m1 minus m2 by a b dash minus b a dash. Okay, then we get m1 by a b dash, this is equal to m2 by b a dash, this is equal to, we putting the value of m1 minus m2 from this relation and getting the result as 2 into b h dash minus h b dash by b b dash by, this is equal to a b dash minus b a dash. Okay, so we get the value of m1, this is equal to, we multiply here 2 into a b dash, that is b dash cancel out, so we get 2a into b h dash minus h b dash by, this is this is b into ab dash minus ba dash. Okay, and similarly the value of m2 by multiplying this we get 2 into here b cancel out, so a dash is here and b h dash minus h b dash by b dash into a b dash minus b a dash. Now in our problem it is given that two lines are coincide and we take the coincident line is y equal to mx in the first line and in the second pair of line. So we can put in place of y in the left hand side of this line is equal to mx, and also in the second line we can put y equal to mx. Okay, so we get the result from this and this. This is given by b m square plus 2h m plus a, this is equal to 0, and b dash m square plus 2h dash m plus a dash, this is equal to 0. From these two line or these two pair of line we get the result by putting y equal to mx in both the line. Now by making cross multiplication we get m square by m by 1 by, and this is given by 2 into h a dash minus h dash a, and this is given by a b dash minus b a dash. Okay, and this is given by 2 into b h dash minus b dash h. Okay, and we get the relation or the value of m square is given by this and 2 to cancel out, so h a dash minus h dash a by b h dash minus b dash h, this is m square, and m is given by a b dash minus b a dash by 2 into b h dash minus b dash h. Right, now equating m square with m square we get the relation a b dash minus b a dash by 2 into b h dash minus b dash h whole square, this is equal to h a dash minus h dash a by b h dash minus b dash h. Okay, and this relation gives the result as a b dash minus b a dash whole square, this is equal to 4 into this one and this one is cancel out, so we get the result h a dash minus h dash a into h dash b minus h b dash. Okay, and this is very important result to prove the given relation. Okay, so we get the value such that this relation and the value of m1 m2. We put the value of m1 minus m2 first, and this is given by 2 into h dash b minus h b dash by b b dash. Okay, and 1 plus we put the value of m1 into m2, so this result gives 4 a dash by b b dash. Okay, and clearly these two factor is same, so we get here in the lower position a b dash minus b a dash whole square, and also b h dash minus h b dash, b h dash, and this two factor is also same, so we get b h dash minus h b dash whole square. Right, now we put the value of this relation. We already find out a b dash minus b a dash whole square. We put this relation is equal to 4 into this and getting the result as, and also cancel out b b dash from upper portion and lower portion. We get the result 2 into h dash b minus h b dash by b b dash here plus a dash. 4 and 4 we cancel, and the upper term is bh dash minus hb dash whole square by this is h a dash minus h dash a into h dash b minus h b dash. Okay, and one term of h dash b and h b dash, and here is also h dash b minus h b dash, so this and this are cancel out, so we get the result as 2 into h dash b minus h b dash by, and since this and this term cancel out, so square is vanish and here present this by this, so we get the result this factor in the upper portion and getting as this is h dash b h a dash minus h dash a, and in the lower portion this is b dash into h a dash minus h dash a plus a dash into b h dash minus h b dash. Okay, this is, now we change tan theta to cot theta, because this value is tan theta but we have to prove the value of cot theta. Then we get the result as cot theta, this is equal to b dash into h a dash minus h dash a plus a dash into b h dash minus h b dash. Okay, by 2 into we multiply 2 here, that is we have to prove 2 cot theta, so we multiply 2 here, and the lower term is h dash b minus h b dash into h a dash minus h dash a. Okay, now separating both the term, we get the result as, we already here given a modulus, so this is mod, and all the term in here is mod sign, is in the mod sign, so we get b dash by, the first one is h dash b minus h b dash, here h a dash, this term and this term cancel out from the first, so we get h dash b minus h b dash, this is mod, minus, or this is not minus, this is plus, this is a dash by, this and this we cancel out, here be h a dash minus h dash a. Okay, and we write this as 2 cot theta. Okay, 2 cot theta, we write first this term, this is a dash by h a dash minus h dash a, minus, we take common here minus from this term, and we get the result as b dash by h b dash minus h dash b. Okay, and this is our required result. We have to prove this result. Okay, this is the second proof or the second part of the problem. We have to prove the first portion of the problem. Okay, that is we have to prove this result. And here it is given that two lines are coincide and other two are right angle. And so we have to some change here, because two lines are coincide, so these are same, but other two are at right angle. So if we take, this is y equal to m1x, so another is y plus 1 by m1x, because these two lines are perpendicular, so m1 into minus 1 by m1, this is equal to minus 1. Okay, this is the condition of perpendicularity, and using these two result from here, this is okay, this is okay, this is right and this is right, but it have to some change. this is given by minus 1 by m1, and this is also given by m by m1. This is minus. We name this is 1, this is 2, this is 3, and this is 4. Okay, we change the name on the equation. Now from 2 and 4 we get 2 and 4 we get. By multiplying both of them we get the result as minus m square. So this is minus m square. This is equal to a dash by b dash. Okay, and this is given by m square. So minus a dash by b dash, that is m. This is equal to root under minus a dash by b dash, right? And from 2 we get here we write 2 imply we put the value of m here and getting the result as m1. This is equal to a by b into root under minus b dash by a dash, because this term in the left side, so we write here in the right side. This is equal to, we can write this result as, this is equal to root under minus a cancel out, so this is a b dash by b cancel out, so we get b dash. Okay, and this is also can be written as a b dash by root under minus a b dash. We multiply a dash in upper portion and lower portion, so we get the result of m1. Okay, now the value of m is also can be written as, this is given by root under minus a dash b dash by b dash. We multiply numerator and denominator by root under b dash. Okay, now we get the value of m and value of m1, and putting the value of m and value of m1 in the relation number 1 and getting the result as 1 imply m plus m1. This is equal to minus 2h by b, that is m. This is given by root under minus a dash b dash by b dash minus, this is m1, so we get this is plus a b dash by root under minus a b dash, and this is equal to minus 2h by b, right? And this is given by root under minus a dash b dash by b dash, and from here we get this is minus a b dash into root under minus a b dash. Okay, by a b dash. This is equal to minus 2h by b. We multiply numerator and denominator by this root. Okay, and now taking common minus a dash b dash from both the term, and we get this is 1 by b dash minus this is a b dash by a b dash. This is equal to minus 2h by b. Okay, and here b dash cancel out, a cancel out, and this relation gives root under minus a dash b dash by b. We also take common b from these two relation, and this is 1 by b dash minus 1 by a dash. This is equal to minus 2h by b. Okay, and b cancel out, so we get the result as root under minus a dash b dash. This is into, we taking calculation or taking LCM of this term, getting result as a dash minus b dash by a dash b dash. this is equal to minus 2h. Okay, now we see that here for this relation we get last two fraction of the required result as we given by 2h into a dash b dash by this is b dash minus a dash because here extra minus, and this is equal to root under minus a dash b dash. Okay, this is the last 2% of the required result. Again, if we substitute the value of m, this value, and m1, this value, in the relation number 3, that is this relation, okay, and we get the result first fraction, this is equal to last fraction. Okay, so we get the result as 2h dash ab by b minus a, this is given by root under minus a dash b dash. Okay, and combining these two results we get the required proof.